Welcome to the GCSE Statistics Higher Session 5. This session is focused on scatter graphs and correlation and consists of 4 subsections as shown here on the screen. Lines of best fit and estimation, equation of the line of best fit, nonlinear models, and Spearmans ranked correlation coefficient. Lines of best fit and estimation. The mean point has a coordinate x, which is found by adding up and dividing all of our x coordinates. It is the mean of the x coordinates. Similarly, the y coordinate is the mean of all of the y coordinates. The mathematical notation used for the mean point is x bar, y bar. This means the mean of x, the mean of y. Sometimes you must calculate this, but it is usually given to you and you are asked to plot it onto a scatter graph. Drawing the line of best fit is really important. The line should go as close to all the points as possible, ignoring any obvious outliers. Make sure you use a clear ruler as it's helpful here as you can see all of the coordinates. Not much tolerance is given by the exam board, so you really need to take care and make sure you're using a pencil so that you can rub out and try again if you think your line of best fit is not in the place which is nearest to most of the points and you wish to do it again. Crucially, if you are asked to plot the mean point, the line of best fit must go through this point. Often these questions are part A, find the midpoint, part B, draw the line of best fit. Now, if you aren't given or asked to calculate the mean point, don't waste time calculating it for your line of best fit, as no marks will be awarded. However, I repeat again, if you are asked to plot the mean point, then you must make sure your line of best fit goes through your mean point. You need to be able to use your line for estimates. Once the line has been drawn, you are going to need to use this line. Make sure you start at the correct axes. So if they give you the female life expectancy and they want you to find estimate the male, you need to start here, up and across to the line. Now you also need to be able to comment on the accuracy of the estimates. And usually all to do with the range of the original data. Here we can see that our data ranges from approximately 80 years to 83.5. If the estimate is within the range, it's reliable. And the mathematical term to describe this is interpolation. If the estimate is outside the range of the data, so for example, if you were having to estimate someone, a female with 100 years, and then looking for the male, it would be outside the range. When this happens, the reliability of the estimate is questionable. The mathematical word that we use to describe this situation where we are estimating outside the range is when it's called extrapolation. So you are extrapolating beyond the range. Example 1. On a particular day, a scientist recorded the air temperature at 8 different heights above sea level. The scatter graph shows the air temperature in Y Celsius here of each of these heights x kilometers above sea level here on the x-axis. Now, first off, we're asked using the scatter graph, this is looking for a coordinate, write down the air temperature recorded at a height of 2.5 kilometers above sea level. So a height above sea level, 2.5 kilometers is here. We're looking for this particular coordinate. Going across, and it corresponds with 2 degrees Celsius. We're then asked to describe the correlation between the air temperature and the height above sea level. We can see here that the coordinates are going down. From left to right, they're going downhill. And this is known as a negative correlation. If they were going in this direction, it would be positive. If they were random, then it would be 0 correlation. So here now we're given the mean point of the data as 1.5, that's here, and 8 here, and asked to plot it. So add a further point here and label it as our mean point, x bar, y bar. And then asked to draw the line of best fit and reminded that it must go through this point. So you need to take your ruler out. As I said, a clear ruler is helpful. And we're looking for a line that's going through the mean point. It must be going through here and then along. And I'm going to move my line down slightly so that it's exactly going through that point there. Okay, now using your line of best fit, find an estimate of the height above sea level when the temperature, the air temperature, is 0. So here now we're looking, the air temperature being 0. So this is where the line of best fit is crossing the x-axis. On my particular graph, it's crossing just here at 2.6. Now on the mark scheme in the exam, anything between 2.6 and 2.9 will be accepted as an answer, a correct answer. So here we're looking at where the line of best fit crosses the x-axis. Equation of a line of best fit. In this case, you must extend the line, if not done so already, so that it meets the y-axis to find the intercept. We're then looking at calculating the gradient. Using a triangle will help you in this case. The bigger the triangle, it's better. It minimizes the error, and always give your answer to 3 significant figures unless told otherwise. This is related to your knowledge already about y equals mx plus c. However, the notation we use here is very similar, but it's y equals ax plus b. A is the gradient, just as m is the gradient in a y equals mx plus c. B is the intercept, just as c is the intercept here in y equals mx plus c. Crucially, it is the y-intercept, where the line of best fit crosses the y-axis. This is why point 1 is important, that we can see here that it doesn't cross, so we are going to need to extend our line here in the same way, so it crosses here the y-axis. Let's take a look at this particular example. This particular example here is about a scientist recording air temperature at 8 different heights, the coordinates plotted, above sea level. Here the datagram shows the air temperature. Here we have in Y degrees centigrade at each of the heights x kilometers above sea level. So we have now extended our line as our first step to be able to find our y-intercept. So for this particular example, we know that we're going to have y equals something x plus 18. Why? Because we're going through the y-axis at positive 18. We then need to find our gradient. We use the triangle and we use the change in y divided by the change in x to calculate the gradient. We're going to use a big triangle. We're going to use the triangle that's created here. If we take a look at our first one, we're going down here. And this is the change in y. That's this part here. The change in y, we can see, goes from here down to 0. 18 down to 0 minus 18. We can then take a look at the change in x. The change in x goes from 0, using our triangle all the way across. We're trying to minimize the error, and we can see here that we're going to 2.75. Positive, we're going from 0 up to 2.75. 2.75 here is going to be the change in x. So we must divide these two values. To find the gradient, we will take negative 18 divided by 2.75. Giving that answer to three significant figures is negative 6.55. Inserting in here is the coefficient, the number in front of the x, 6.55. This here now is the equation of our line of best fit. A is minus 6.55, B is 18. Now you may be then asked for a practical interpretation. What does this line of best fit mean? Well, first off, we can see that we have a negative gradient. This shows us that the number of degrees that the air temperature drops for every kilometre above sea level. So you need to be able to interpret this equation in relation to the context of the question, using air temperature, using height, and using our numbers here in our equation to be able to give practical definition. Now, non-linear models. You need to be aware of the existence of non-linear alternatives to a line of best fit. You won't have to plot these, but you'll have to identify the general shape of the three curves. So our first one here, y equals x squared, and we may have a constant in front, it may be y equals 2x squared. On a quadrant here is going to look something like this. So a curve going up in this shape will correspond to our first type of graph here. Our graph here, y equals the root of x, is going to be a graph that's coming in this direction. So similar to this one, but coming up from the y-axis. And our last graph here, which is a reciprocal, y equals 1 over x, your graph is going to be coming along, forming asymptotes to both the x and the y-axis. So you need to identify these three different types of curves. The question will look something like this. You're given the scatter graph here, and you're asked to put a cross to indicate which one of the equations is the best model for this data. So looking here at the shape, the answer is here. Y equals a, which just is the constant, x squared. Spearmans rank correlation coefficient. This enables a value to be given to the correlation. You don't need to know what conditions you use it in, rank or non-bivariate normal data. You just need to know the mechanics of how to do it, how to calculate it. And questions are all virtually identical. The formula is on the exam paper to help you. It's just here, I've screen printed from the exam paper here. And you need to show all your working. Be careful of rounding, try and keep your numbers as accurate as possible. And when you're calculating D, the difference between your two ranked pieces of data, you should show if it's add or subtract, whether it's a positive or negative number. Even though when you square it, all the negatives will be eliminated. So try and keep these accurate when doing the difference. And we'll have a look at one of those in a moment. The correlation coefficient should be shown as on the calculator and then rounded to 2 decimal places, unless otherwise told in the question. So when you're using with the calculator, as with any questions, writing down all your working out, writing down every number on the calculator, and then round appropriately. If you're asked to interpret the figure, you need to speak about two different things. First off, the correlation. A number, -1, is perfect negative correlation. So any number that's close to -1 will be a negative correlation. In the middle here, we have 0. 0 correlation. 0 as your value for the Spearmans rank correlation coefficient is a 0 correlation. So anything close to that is near 0 correlation. And then on the other side, 1 is being the positive. the perfect positive correlation. So your number that will come out for Spearman's rank correlation coefficient must be a number between -1 and +1. The closer it is to this one, negative. The closer it is to 1, positive. And you might need to describe what this means in the context of the question. Okay, so that's using the axis, using what this question is about, and describing. So for example, if it's a negative correlation, we can see here in our previous example, the higher above sea level, the lower the temperature. That's one going up, one going down, and that's a negative correlation. Example number 4. 10 schools each entered a team of boys and a team of girls in a swimming gala. The table shows the points by the boys' teams and the girls' teams for each of the 10 schools. Here we have their points. Our first step is to rank the boys' team. So which team came first? Which team had the highest number of points? We can see here A, 19 points, first. Second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. Here, number 1, the lowest number of points. We can see here, this is also 10 as the lowest number. This is 9, 8, working in the right direction, 8, 7, 6, 5, 4, 3, 2, and 1. So that's our highest scoring team here, school F for the girls, 17 points. Now we're provided with extra columns to be able to work out the difference and then the difference squared. So we're looking at here, we have our boys' rank of 1, subtract our girls' rank of 2. So 1 take away 2 minus 1. 6 take away 3 is 3. 4 take away 1 minus 1. 9 take away 7, 2. 5 take away 5, 0. 2 take away 1, 1. 7 take away 6, 1. 8 take away 9 minus 1. 4 take away 8 minus 4. And 10 take away 10, 0. Then our difference, so we're going to squared. So all these numbers squared. 1, 9, 1, 4, 0, 1, 1, 1, 16, 0. Okay, so to be able to calculate our Spearman's rank correlation coefficient, we need to find the sum of d squared. So the sum of d squared. Adding up all these numbers, we have 16 plus 4, 20, 1, 2, 3, 4, 5, plus our 9 is equal to 34. Now, the other thing we need for the Spearman's rank correlation coefficient is n, the number of values here we have 10 schools, so n is 10. Now, looking at your formula book, we're told that the Spearman's rank correlation coefficient is calculated by 1 subtract 6 multiplied by the sum of d squared, all divided by n, the number, brackets n squared minus 1. So we're going to take our values now and substitute them in. Again, show all of our working out. 1 subtract 6 times 34 divided by 10 bracket 10 squared subtract 1. Working all of that out, we get a value of 0.79. And we're asked to describe this correlation. So this is interpreting what was this near to. Remember on our scale, -1 negative, 0, 0, 0, 0 correlation, and 1 positive correlation. This number, 0.79, is closest to 1 here. So this will be a positive correlation. And we're asked to write down what you can conclude about the relationship between the teams of boys and the teams of girls in the same school. Because it's a positive correlation, we can see here that schools with good boy swimmers also have good girl swimmers. So the better the girls are in a school, the better the girls are. And conversely, the lower the girls came in one school, the lower the boys came. So here, an easy way to describe that would be to say schools with good boy swimmers, this is what the question is about, also have good girl swimmers. So there's a correlation. The better the boys are, the better the girls are. The worse the boys are, the worse the girls are. So it's now time for you to do some questions. Press pause on the video and complete the question booklet. Once you've completed as many questions as possible, come back to the video and we will go through the questions together. Question number 1. Sprinklers are used to water similar plots of land on an experimental farm. The table here shows the amount of water applied in centimetres here and the amount of hay here grown in tonnes per acre on each of the 7 plots of land. We're told that to plot the last 3 points from the table. That's these points here. Onto the scatter diagram. So taking a look here, our first point, x, 25, the amount of hay, 7.3. Taking a look here, we've got 7, 7.1, 7.2, 7.3 is here. 7.4, 7.5, yes. Our next value for x is 30, and the amount of hay is 7.9. So here to 8 and 1 down. And our last point here to coordinate to plot is 35 and 8.1 here. Make sure those go in the correct place. We're then asked to describe the correlation between the amount of water applied and the amount of hay grown per acre. We can see here that the points are in an upward trend. So we can see that this, B, is a positive correlation. What does that mean in the context of this question? Well, as we increase the amount of water, the amount of hay increases. We can see here, lots of water, lots of hay. Less water, less hay. So our positive correlation means that more water, more hay. Or conversely, less water, less hay. We're then asked to calculate the mean. To be able to calculate the mean point, we are going to need to find the mean of x and the mean of y. We find the mean of y and the mean of x by adding up these values. First off, x, we're adding 5 plus 10 plus 15 plus 20 plus 25 plus 30 plus 35 and dividing by 7. You then need to do the same for y. When you do that, you will get your mean point of 20 and 6.5. You then need to plot this point on the scatter graph. I'm going to use a different colour to make sure I know clearly that this is the mean point. 20 and 6.5 here. When we draw our line of best fit, it must go through this point. So taking your ruler now to draw your line of best fit, making sure that this line goes through our midpoint. So here, extending through, must go through this point. Extending, again, using a clear ruler will help you when doing this question. See, approximately there. Okay, now this is drawn, we're going to need to use it. So first off, we're asked to estimate the amount of hay grown when 32 centimetres of water is applied. 32 centimetres is here. 32 centimetres up and across is going to give us a value of 8. We can see here, at this point here, touches the line and across 8. So our first part for part E gives us a value of 8 tonnes per acre. You need to check your line of best fit, and you need to check that your answer is somewhere between 7.9 and 8.1. This is the range of values available in the mark scheme for this question. Now we're asked to extend the line of best fit to find the amount of hay grown when no water is applied. When we go down here, we can see that no water is at this point, 0. And we can see here that our value looks like it's coming out as 4.1. So by extending our line, we see that we have 4.1 tonnes per acre. We're asked to discuss this answer. This suggests that there is some words or sentences that you will want to associate with this answer. So first off, 0 water gives us 4.1 tonnes per acre. Now what is this? This is the amount of water, the amount of hay produced with no water. No water, the line suggests that we can have 4.1 tonnes per acre. How is that? Why is it growing? Maybe this is only to do with rainwater falling, rather than water being fed to or applied to the hay. You may also want to mention that we are estimating outside the range. Estimating 0 is not within the range of data that we have here on our scatter diagram. Therefore, this may not be reliable. Again, if you want to use the mathematical word to describe this, in this case, we are extrapolating. We are going beyond the mean, and therefore the answer achieved here, 4.1, may be unreliable. Question number 2. The scatter diagram shows the ages, x million years, we can see here, of a skull, and the volume of a skull here, y centimetre cubed, of 8 skulls of a particular type of ape. We're asked to describe the correlation between the volume of the skull and the age of the skull. We can see our points are going downhill. This is a negative correlation. The table gives ages of x million years and the volumes in y centimetre cubed of the 8 skulls shown in the scatter diagram. So this information is up here. We do not need to plot any, but this information has been provided so that we can work out the mean point for these data. So first step, adding up all of our x coordinates, we get 11.2 divided by 8. There are 8 skulls. To be able to find our mean point, 1.4. Doing the same with the y values, adding up all the y values, 904 divided by 8 gives us a mean of 113. This is x bar, this is y bar. We asked to plot these onto the axes here. 1.4 is at this point here, 1.4, and 113. Here we have 125. Each one of these represents 5. So 113, here we have 105, 110, and a little bit above there for 113. 113 and 1.4 is here, labeling it up as the mean point. Now, once that mean point has been identified, you're often then asked, as in this question, to draw the line of best fit. This line must pass through our mean point here. So it must be going through the mean point. Excellent. So take a look here now at this question. We've completed the mean point and we've drawn the line of best fit. We then are told that a skull of this particular type of ape has an age of 1 million years and asked to estimate the volume of this skull. So we're looking here now at 1 million here. We're going to take our ruler out and we're drawing a line from this point, 1 million, up to the line of best fit and then a cross. Now we can see here we're just below 150, approximately 145. Here on the axis, 145. Again, the exam board offers a range of answers. You need to make sure that your answer is between 130 and 170. We're told that the skull of another ape is to be classified. It has an age of 1 million years, that's the same as this one, and has a volume of 75 centimetre cubed. We're asked to discuss whether this skull is likely to be from the same type of ape. Well, here we can see the age is exactly the same. The skull, it's about 1 million years. But the volume is significantly lower, almost half. So do you think this skull is likely from the same type of ape? No. The difference in volume is just too large. Now, you might want to then go on to say, but there may be a reason for this. So, for example, this ape could be the same type, but it could be a baby ape or a young ape, and therefore the skull, the volume of the skull, is significantly lower. We're then asked to give a reason why your line of best fit may not be used reliably to predict the volume of a skull with an age of 3 million years. So taking a look back here, 3 million years is here. Looking at our line, how can we predict 3 million when if you extend our line, we are going to get a negative volume. It's below 0. So asking you a reason why this may not be reliable use, first off, it's going to give us a negative volume. And this is not possible. We cannot get a negative volume for a skull. Moving on now to the equation of the best fit, line of best fit. We're told the form y equals ax plus b, and we're asked to use our line to find the value of a and find the value of b. So let's take a look at our graph here. We need to first off extend our line so that it goes through the y-axis. So extending our line here, going through the y-axis. And we can see here that it's hitting at, this is 225 halfway, 230, 235, 240 for this line of best fit. So y equals ax plus b, this part plus 230. In the exam, this can be anywhere between 200 and 250. So just check that your line of best fit is giving you a value between these two ranges. Okay, to find a, we're looking at the gradient, the difference here in y divided by the difference here in x. Now on this particular line of best fit that's been drawn, my difference in y on using the large triangle is 230. Sorry, 240. We said that one was 240 from here. 235, 225, 35, 45, 225, 230, 235, 240. So our value is 240. So our value here is the difference in y is 240. Then when we have a look here along the x-axis, our value here corresponds to 2.6. So 240 divided by 2.6 gives us our gradient of 92.3. This is a negative gradient, so y equals minus 92.3x. So I'll rewrite that out again down below, that our equation is y equals minus 92.3x plus 240. Again, with the regions here, this one can be anywhere between minus 60 to minus 100. And this number here, 200 to 250. So just make sure that your numbers for A and B are somewhere between these two values and these two values. We're then asked to give a practical interpretation, as we often are, of A. This is this part here. So, using the words, the context of this particular question, A is the decrease, remember we have a negative gradient here, the decrease in volume for each of the million years. So for every million years, the volume decreases by this amount, in this case 92.3. So A is the decrease in the volume for each million years. Question number 3. The diagram below shows the body lengths and wingspans of the same birds. The diagram shows a positive correlation. What can you conclude about the relationship between the body length of birds and its wingspan? So here we need to interpret the positive correlation in the context of this particular question. We can see here that as body length increases, the wingspan increases. We can say it the other way around, as the body length decreases, the wingspan decreases. So here we need to talk about what positive correlation means for this particular question and context. We're then told that a line of best fit has been drawn on the scatter diagram. We can see that here. We're told that the equation for this line of the best fit is in the form y equals ax plus b, and asked to work out the equation of this line. So first off, remind ourselves y equals ax plus b. B is the y-intercept, where the line crosses the y-axis. And we can see here clearly that it's at this point here. 0 to 20. 5 squares, each square must be therefore equal to 4. So we know our first part here is equal to 4. And that's positive 4, as we can see here, it's a positive value. Then moving on to finding the gradient. Again, the gradient is found by taking the difference in y and dividing by the difference in x. Also can be expressed as the change in y divided by the change in x. Now in this case, you need to pick a triangle. The bigger you make the triangle, the more accurate you will be. Here we can see that we can go here from 4, and we're looking for somewhere where we're going to have a crossing point that actually lines up with the line of best fit so that it is not on a half square. So if we progress all the way over here to this point here, we can see this is easily halfway between 100 and 125, sorry, 100 and 150, which is 125. And when we put our line up, we can see that this point here is nice and neat. It fits exactly on the square. So it's going to make it easier to make the calculations as accurate as possible. So here we can see that we're exactly on the line. Now, what are the actual values? Well, the difference in y here, we can see we're going from 4 all the way up to here, which is 68. So we're actually going up 64. On this particular triangle, remember you can choose a smaller or a larger triangle, but you will get the same answer for the gradient. The ratio will be the same. Looking here now at the difference in x, we go from 0 to 125, so that's simply 125. Dividing these two values, we get the answer of 0.51. This is the gradient that belongs here as the coefficient of x. So when asked to write down our equation, we have y equals 0.51x, add 4. We're then told that a crow has a wingspan of 100 centimetres and asked to estimate the body length of this crow. So having a look back here, we can use our line or we can use our equation. If we look at our line here, we can say 100 is here. Take your line up, take your line across, and you're looking at somewhere just about there. So not quite on a full square. Let's have a look at what this value is here. We've got 40, 44, 48, 52. A bit higher than 52, but a bit lower. Here we can see lower than 56. And actually on the mark scheme, it accepts an answer between 52 and 56. So using your line, you will see that it is somewhere between 52 and 56. Now you might want to use your equation that you have here that you've just worked out by substituting. So we then have y equals 0.51 multiplied by 100. That's your value for x. Add 4. We have 51, add 4 gives us 55. Again, it's within the range. So we've got two ways here that we can estimate, both from the graph and from the equation for the line of best fit. Question number 4. 2 judges had to rank 6 gymnasts. Here are the rankings. So we've been given the rankings straight away. These are not points. So Judge 1 thought that gymnast E came first, as did Judge 2. We're asked to use this information to calculate Spearmans' rank correlation coefficient. So our first step is to calculate the difference between the two rankings. So in our first case here, 0, here, 1, minus 1 actually, here 1, here minus 1, 0, 1. We then need to calculate the difference squared, which we can do underneath, 0, 1, 1, 1, 0, 1. The sum of the difference squared is equal to 1, 2, 3, 4. And n is equal to 6. We have 6 different gymnasts here. So we're going to substitute these two values into the formula that we have to calculate the Spearmans' rank correlation coefficient. 1 subtract 6 times 4 divided by 6 bracket 6 squared minus 1. This gives us an answer of 0.886. We're then asked to interpret this answer. We can see here that this number is very close to 1. So we have a strong positive correlation. But what does that mean in the context of this question? We have 2 judges. The relationship between their 2 rankings, what one judge thought and what the other judge thought, was almost the same. So the judges agreed on the ranks. And we can see that by looking at the numbers. The best gymnast, they both thought was the best gymnast. Here, the gymnast that came 5th and 6th, they didn't have exactly the same, but they both thought either this one was 5 and this one was 6, and this one was 6 and this was 5. So there is a strong correlation, and this interpretation is that the judges agreed on the ranks given. Question number 5. Table 1 shows 7 countries selected at random, their HDI, Human Development Index. This is a measure of their quality of life, and their GNP, Gross National Product per person, a measure of their wealth. Here we have the table for the different countries. We have 7 countries, N is equal to 7. We're then given another table with some spaces in. The rank for the Human Development Index has already been calculated. We need to calculate the rank for the GNP. By doing this and filling in this table, we're going to be able to work out the Spearman rank correlation coefficient. And then we're asked to interpret this. So looking at the GNP, we're looking for the highest value, which is for Oman. That gets rank number, not Oman, the UK, 113. So rank number 1, Oman is 2nd. Change that into a 2. Followed by Cuba, 3, 66. Followed by Rwanda, 4. India, 5. China, 6. Niger, 7. Okay, so these are our rankings now, and we're going to find the difference. 0, 2, 0, 2, -3, -1, 0. And then we're going to calculate the difference squared. 0, 4, 0, 4, 9, 1, 0. Adding up these values will give us the sum, the total of them, of D squared. Adding up these values gives us 18. N is 7. The sum of D squared is 18. Remember the formula from the front of your formula booklet. 6 sum D squared divided by N bracket N squared minus 1, all in a bracket and subtracted from 1. So substituting in our values for this particular question, we get 1 minus bracket 6 times 18 divided by 7, close brackets, 7 squared minus 1, all close the brackets. Calculating this through using your calculator, giving your answer correct as 3 decimal places, 0.679. Interpret your answer to part B. This number here is towards 1, but it's not that close to 1. So we can say here that we have some positive correlation. It's not strong. We could say a weak positive correlation. What does this mean in the context of the question? Well, our 2 values that we're looking at here are HDI and GNP. So if there's some positive correlation, the higher the HDI means the higher the GNP. We've now come to the end of session 5. Please revise the list of subtopics shown here on the screen and replay the video for any sections that you would like to study again.